Okay, awesome. Okay, so where were we? Okay, so we were looking at the concept of a tidy data in R. So, like I said, a tidy data has three principles. Number one is that each variable has a column, each observation has a row, each value has a cell. So once a data set captures these three principles, we call it a tidy data in R, and R can work effectively on that data. Okay, so let's move on to the next topic, which will be, so identify special operators in R and their functions. Okay, so let's look at operators in R. Okay, so R has what we call operators that help it to work, to connect things together. So we're just going to be looking at a few of them. So number one is, which you have seen me use, is what we call the assignment operator, which is what is represented here in this bracket. An assignment operator is the less than sign and the minus sign joined together. The less than sign and the minus sign together, that's the assignment operator. However, on your keyboard, you can use alternate and minus sign. Alternate and minus sign to create this operator. So yeah, so you can try that out. If once you are in the R environment and you click on alternate and then the minus sign, you get this assignment operator. You can also do it manually by typing the less than sign and the minus sign. It's just that it's faster when you do it alternate and minus sign together. So the assignment operator is, like the name implies, is used to assign things, to assign one thing to another. For example, when we assigned 30 to my age, so that's what an assignment operator does, is effectively used to save objects in R. So that's an assignment operator. You'll see us use a lot of it as we go on. Number two, we have what we call the pipe operator. Please, can you put your speakers on mute so that your voice doesn't interfere with our communication?
Okay. Please, I'm just joining in. How much have I missed?
No, you haven't missed much, and it's being recorded. So
thank you.
Okay, so I was just talking about operators in R, and I said operators in R are like connectors which R uses to connect one thing to another. And I said we're going to look at a few of them. Number one is the assignment operator, which you saw me use when we assigned 30 to my age and assigned 58 to your age. So basically, an assignment operator assigns one thing to another. So in R, it's usually used to assign maybe like a code or a value to an object. So as we go ahead, you will see us use a lot of it. And I said to do this is just the less than sign and the minus sign. That's what an assignment operator is. The less than sign and the minus sign. And to type it in your system, you can just do alternate and minus sign. So you click alternate and minus sign together. Alternatively, you can do it individually by typing the less than sign and the minus sign. It's just that using the alternate and minus sign makes it a bit faster for you. So the next operator is the pipe operator. And the pipe operator is this. So it's a percentage greater than percentage. So that's it's assignment, sorry, a pipe operator. And a pipe operator, like the name implies, is used to pipe one thing into another, just like the way if a funnel is. You pipe one thing into another, and it's used very diversely in what we call the tidyverse package, where we are working step by step to manipulate data, and then we pipe what's on the left-hand side to what is on the right-hand side. You will see more of this as we go along in the training. And then to type this pipe operator on your system, you can just click Control and Shift and M together. Control, Shift, M. Alternatively, you can also type it by the signs you're seeing. So you can type a percentage and then a greater than sign and then another percentage. It's just that using Control Shift M makes it faster for you. Okay, the third one is what we call the in operator. The in operator is usually used when we are coding. We want to say if an object or a variable contains one or two or more of what is in a bracket. Let me give you, let me write an example here. Let's assume we're looking for name. Name is a variable, and we now put in this in operator. In, and then we usually put in our C, and we say Lydia, Mutala, Solomon. So let me assume we have a data set of everyone that is in this training, and I want to get out just these three names from the name variable. Usually it's used with the filter function. So let me put in filter here and then put in this. So what this code is effectively saying is, within this name variable, if there is any name which is Lydia, Mutala, or Solomon, I want you to filter it. So this operator, in effect, is like any of this, Lydia, Mutala, Solomon, that is within the variable name. So that's what this in operator is used for. We'll see more of it as we go along in the training. I just want to introduce them to us. So I'm going to remove this. Okay, then we move to what we call the arithmetic operators. And the arithmetic operators are just our usual mathematical operators, which is the addition sign, the subtraction sign, the multiplication sign. So multiplication in R is not X, it's this asterisk. And then division sign in R is this slanted bar. So these are arithmetic operators in R, and we could use them. Okay, let's go back to our R Studio so that I can demonstrate the use of these arithmetic operators. Okay, so I can say 5 times 2. So this asterisk sign means times. So 5 times 2, click Control Enter. If you look at the console, it has brought down the code which I wrote, which is 5 times 2, and then it still does the answer is 10. I can say 8 divided by, which is the slanted bar, 4. Control Enter, it brings down the code, which is 8 divided by 4, and it tells me the answer is 2. I can say 100 minus 98 or 97. Control Enter, I have my code 100 minus 97, and it tells me the answer is 3. I can also say 45 plus 5, control enter, and tells me the answer is 50. So that's the use of the arithmetic operators in R. Okay, so going back to our operators, then we'll have what we call the relational or comparison operators. And we use them either to compare one value to another or to relate one thing to another. And examples are the greater than sign or the greater than or equal to sign. We'll have the less than sign. We'll have the less than or equal to sign. We'll have the double equal sign. And then we'll have the not equal to sign. This exclamation mark here means not. So this is not equal to. For example, I can say 8 is not equal to 7. So that's what I mean by this. So 8 is not equal to 7. So these are what we call the relational operators. So greater than, less than, greater than or equal to, less than or equal to, double equal to, and not equal to. This double equal to is usually used most often in our filter function. We'll see how we use it as we go along. Then we have what we call the logical operators. Logical operators include the and sign, which is this, the or sign, which is this long bar. On my keyboard, where I have the the backward slash sign, above it, that's where I have this long bar. I don't know if your keyboard is the same as mine, but that's where I have my own long bar, and it means or. And then we also have the exclamation mark, like I said, which means not. So these are what we call logical operators. And then we have our exponential. An exponential is like saying something raised to the power of another thing. So this sign for me is above number 6 on my keyboard. So if I click on Shift and number 6, it will give me this exponential sign. So if I say 2 raised to power 3, that means 2 times 2 times 2, which is give me 8. So that's this exponential sign. We also have another one we call the integer division. Now, what integer division tells us is, for example, 22 integer division 5 tells us how many of 5 can we find in 22. That's what this statement is saying. How many 5s can we find in 22? And 22 divided by 5 is 4 remainder 2. So we can find 4 5s within 22. So that's what that operator means. Then we have another one we call the modular operator, which is a double percentage. And what this means is, for example, if we say 22 modulo 5, it means what is the remainder when we divide 22 by 5. So 22 divided by 5 is 4 remainder 2. So the answer will be 2. Just what is remaining when we divide these two figures. Okay, so I know they're a bit many for us right now, but as we continue to use them, we will get used to all these operators. Fine, let's move ahead. So next, we will be looking at creating an R project and opening and saving a new R script. Okay, so we'll go back to our R studio. So usually when you want to create a new project in your R studio, you just come to File, click on File, and then you click a new project. And what does R mean by projects? Projects are like when you're working on a particular, I don't know what to use except project. Let's assume, okay, as an epidemiologist, I'm doing a work on knowledge, attitude, and practice for health workers on a certain disease. I'm also doing work on identifying the microbiology of a particular disease. I'm also doing some work on knowing the surgical outcome of a particular surgical procedure. So each of those things can be a project for me. So I can create a project for data analysis for each of them. So that's what really R is, so that everything that pertains to that particular project, every document, every file, every script is neatly arranged within one project folder. So that's the relevance of creating projects. So like I said, you come to File, and then you go to New Project, and you click on New Project. Okay, first it's telling me to save the, so a good thing, let me cancel this. A good thing is, as you're working in R, it's good to save your work, so that you don't lose your work. So I opened up this new script as we were started this session. So I'm just going to save it. So I go to Save As, and then I'll say November batch training. And then I click on Save. So you can see in the name of my script, it's now November batch training. So it's saved. So let's go back to creating a project. Go to File, New Project. So I click Save. So it opens up this dialog box for me, and it gives me options. Do I want to create a new directory, or do I want to go to an existing directory? A directory is like a pathway for that project to be able to source whatever documents that you want. So if, for example, I have a folder in my system where the data sets for that particular project is in, I can go to existing directory. If not, if I want to create a new project from fresh, I click on New Directory. So let's assume I want to get something from something I'm already doing. I can click on Existing Directory, and then it will bring this place for me, and it will now bring this browse. So I can browse and go to the particular folder in my system where I want my folder to be placed. So if I click Browse, there's a project I'm doing on knowledge, attitude, and practice of health workers on cancrum oris, a disease called NOMA. So I can go to, it's inside my documents. In my documents, it's in a folder called Cap2. So I can click this. So I'm inside the Cap2 folder now, and I can click Open. So it has put in the address of that folder here. So I can just click on Open. If I wanted to open, once I close this box, I click on Open a new session, and then I come here and I click Create Project. So it opens up a fresh project for me. So usually one like Lydia, once you open up a new project in RStudio, it first of all gives you 3 quadrants like this. So if you want the 4th quadrant to appear, you come to this box, this upper outer right corner here, and click on this 2 windows. Once I click on it, the 4th quadrant, which is the source quadrant, would appear on top of this. Another way of doing that is also to create a new script. So I can click on File and then New R script. But I'll just click on this one here, and you can see this 4th quadrant has appeared. So you now have your 4 quadrants. Okay. Excuse me. So that's how to create a new. So you can see the new project I've created is this cap2. So this blue circle here with an R in it shows that is a new project whose name is cap2 in RStudio. And then within that folder, I already have some files. Like this is the data set. This cap phase 2 is the Excel sheet that contains my data set, which I'm using for that project. It also contains another Excel sheet here, which is for some payment document I did. So all the things that are already in that folder appear in this folder environment. And then this cap2 is the project itself. So everything is neatly arranged for you in this place. Okay. So, and then if we want to create a new script, it's the same thing. Go to File, go to New File, and then come here and press R script, and then create a new script for us, which is on this Untitled 2. If I want to save it with a different name, I can save it and say, okay, call it Lydia _file. So you can see my new script is called Lydia _file in this place. So that's how to create a new project and then a new file, a new script in R.
So
Okay.
please, can I ask a question?
Yeah, go ahead.
Okay, I was trying to follow you on the R as per creating a new project, right?
Yeah.
But since I don't have any existing file, I want you to just, if you can just take us through that new directory.
Okay, so you go to new project.
Yeah, I'm already at new directory.
Good. So you click on new directory, and then you click on new project.
Okay, new project. Then I name it.
Yeah, then you name it. So let's
Can
say
just give it any name.
Lydia.
Okay.
Project. And then you click on create project. If you want it to open as soon as you close this box, you click on this open a new session, and then you click on create project. Now you need to note this create project as a subdirectory of, so that you know where your computer is putting that project in. So you need to note this, yes. And then you click on create project. So it creates a new project for you. So you can see here, the name of this project is Lydia project. You can see? And you can see in the files, it has already put the project here. So every other document that you work concerning this, let's say you import a data set, it appears on this place. So whatever document you work on, maybe you save a Word document or you save a graphical picture, everything appears neatly for you under this project because everything is related to this project. So like I said, it's 3 quadrants that you first see. So you click here so that your 4th quadrant can show.
Yes.
Yep. Okay.
Thank you, sir.
You're welcome. So I close that. Let me also close this one so we can get back to this. Okay, so let's look at the next thing we're supposed to do. Okay, so we've created an R project, open and save the R. So it says install packages in RStudio. Awesome. Okay, so for you to, once you want to start work in RStudio, the first thing you need to do is actually install and load the packages, which is the toolbox that you're going to be using. So as we go along in data management process, we'll begin to know what packages are essential for which particular data analysis we want to do. For example, for myself, when I want to, I've done analysis to an extent that, okay, I have identified certain packages that I need for my own analysis. It might be different for different people. R has hundreds of packages, and different packages may do similar things or may do different things. So it takes, as you keep practicing, you will identify that, okay, this package is useful for me for this particular work I'm doing. Let me give you an example. When I started, there's a project I'm doing on knowledge, attitude, and practice. So after I had done a few analysis, I discovered that, okay, if I use these packages, there are like 11 of them. If I use these packages, it can satisfy whatever work I want to do in R for my data analysis and data management. So these are usually, so once I want to work with any data set, I just come here and copy this code and then go to the script I'm working on and I just run it. And I know once I run this, it has almost every function that I want to use in data. But for startups, let me clean up this so we can start. For startups, once you open up your new script, usually you want to install the packages. Now, there's a package called tidyverse in R. And tidyverse is special in that it's not just one package. It's actually a package containing different packages. So when I describe a package, it's like a toolbox. So now let's assume we have an electrical toolbox. Let me go to pictures again so we can see what I'm saying. Okay, so for example, we said a package is like a toolbox, and there are different packages. So there are different toolboxes. So for example, this is it a carpentry now or an electrical toolbox? I don't know which one, but this is a toolbox on its own. So this is one package. This is another package containing different sets of tools. So each toolbox is a package containing different functions in it. Now, tidyverse is like a package containing different packages inside it. So if I use tools, for example, tidyverse can be a company where there is a carpenter with carpentry tools, an electrician with electrician tools, a water sanitation expert with plumbing tools. So that's what tidyverse is like. It's one big package that within it, it has different packages inside. For example, let's go back to our R studio. So for example, tidyverse has within it, it has the dplyr package. Dplyr is a package on its own. It has the ggplot package, ggplot2 package. It has the forecast package. It has which other package? So you can see dplyr alone is a package. Dplyr, this dplyr is a package on its own that has different tools. So within dplyr, we have tools like select, mutate, filter, summarize, etc., etc. So dplyr is a package that has functions inside, but tidyverse has dplyr in it, has ggplot in it, which is also another package, so it has different packages in it. So for startups, what I usually advise is once you come to R, you want to install this tidyverse, which with tidyverse, you can actually do considerable amounts of data analysis with tidyverse alone. So you can just say, and to install packages in R, you use the install.packages. So this is it here. and then you put in the package inside this bracket. But first, you need to put in your inverted commas. So I put in tidyverse. And then I click Control Enter. So it installs tidyverse for me. But besides installing, you also have to load the package. So installation is one, loading is another. So you can see it's installing the tidyverse inside my system. And here it writes package tidyverse successfully unpacked. So which means it has installed my tidyverse. And then after installation, you need to load the package. And loading the package, you use library as the function, and then you put in your tidyverse. But here you do not need to use inverted commas any longer. So just library and then put in the tidyverse in bracket. So Control Enter, saying error, blah, 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 blah. Okay, yes, but just know that this is the function to use. First of all, you install the package and then you load the package using library tidyverse. So, but assuming I didn't have tidyverse and I needed to load different packages. So let's assume I have installed the packages and then I needed to load deployer package, comma, ggplot2 package, comma, forecats package, comma, real package, comma, here package. So I need to install these things like this, and then I click Control Enter. Oh. So it will install this basically. So you can see in the console here, it's saying package deployer is in use and will not be installed. And that's because I have installed deployer on my system already. And installation is only done once you've installed once, you don't need to install again. However, when you're starting any new script, you have to load the package. So this library code is what you need to do each time you are starting a new script. But if you have not installed the package before, then you have to install. But if you've installed before, you don't need to install again. All you need to do is do library this. But because this is a bit what's it called? And then now if I've installed these packages, I now have to load them, and I will now say library deployer, and then I can't load more than one package at a time using this library function. So I have to do library deployer. I have to do library ggplot2, and then I have to do library, what's the next one? Library forecats. So I have to load each of them individually. But R now developed a simpler way of installing and loading packages, which is what we call the Pacman package. So using the Pacman package, you can install and load any other package that you want to use in R. But first of all, what you need to do first is you need to install the Pacman package. So use install.packages and install your Pacman. Always know that if you're using install.packages, the package has to be in inverted commas or in quotes. So I install Pacman. Pacman means package manager. It's just a short form, package manager. So once I install this, Control Enter, it installs, you can see it says again, package Pacman is in use. And that's because I've installed Pacman before. So once I do this, the next code I want to do is Pacman, I put double colon, and then I put p_load, which means package load. And then I open up my brackets, and then whatever package I choose to use in this data analysis, I can just write it here, and I don't need to use inverted commas. So I can put tidyverse, I can put forecats, I can put real, I can put here. So whatever package here I put. So this helps me, this pacman : p_load. What it does is it tells R whatever is inside this bracket, install it. If it's already installed, load it. So that's the information that this code is telling R. So if I type this, because tidyverse, forecast, real, and here are already installed on my system, it doesn't have to install them again. It will just go ahead and load them. So if I click Control Enter here, so it will just load these packages for me. So this is what I advocate that you use once you can see it's loading them for me. So once you start any script, this code, these two codes are what you need to use. So first of all, you do install the packages, install pacman package, which means package manager in inverted commas. Once you do that, then you do pacman : p_load, and then you put in any package that you separate them by commas, any package that you wish to load, and then R will install and load that package for you. We'll have less than a minute. This session will end now. I will send the Zoom link for the next session immediately, and then we can log on and continue. Thank you.